Dear students, I am Dr. Shanmu Kuchwal from Angadi College of Commerce and Science, Sangha Road, Belgavi. Today, I am going to discuss one of our important topic in 10th standard, that is Introduction to Trigonometry. And I will tell you the simple trick how to remember the formula which are going to appear in the exercises. It is there in a syllabus of 10th standard Introduction to Trigonometry. Yes, let us begin that. First, we will discuss what is meant by a trigonometry. You can see here it is a combination of three words, that is a trigonometry. Tri means it is a three, gono means sides, metry means measurement. Three sides measurements, we call it as a trigonometry. You can see here that I am going to construct a right angle triangle. So you know the definition of a right angle triangle. In a triangle, if any one side is 90 degrees, such type of a, you can say, triangle, we call it as it is a right angle triangle. Opposite to right angle triangle, it is called as a hypotenuse. I write it as a HYP. Here, you might be studying in a 9th standard, find the value of x. Here, instead of x, I am using as another one notation as a theta. So, what is this theta? It is a new term to you. So, usually we will tell find the value of x. So, this concept of trigonometry, first time it is studied and introduced by Greek mathematicians. Greek mathematicians, they used their own alphabet as a theta. So, we represent instead of a x, instead of any English alphabet, we represent it by a Greek letter, that is a theta. Okay, you'll come across this. So opposite to this theta, we write it as a opposite side, and third one, whatever side it is remaining, it is called as a adjacent side, or another name is it is a base. So once again I will explain this. Opposite to 90 degree, it is a hypotenuse. Opposite to theta, it is the opposite side, and the third side, whatever you are getting, so we call it as a adjacent side. Now we define 6 functions of a trigonometry. It is new to you, and I will tell you the easy trick, easy way to remember. So your 8.1 exercise, you will come across 6 trigonometric ratios. I call it as a 6 heroes of a trigonometry. Now how to remember this, I will tell you the easy technique. So first function is, it is a sine theta. Sine theta is, you can refer a diagram here. With the help of a diagram I am writing this. Opposite side divided by hypotenuse is a sine theta. Yes, I am following the direction. It is moving in a clockwise direction. So sine theta is opposite divided by, it is a hypotenuse. Next trigonometric function, it is a cos. So angle is theta, cos theta I write it. So I move in a anti-clockwise direction. That is adjacent side divided by hypotenuse. So what is a cos theta? It is the adjacent side divided by hypotenuse. So now third trigonometric ratio we have to define, that is tan theta. Tan theta is one definition. We have to take a ratio of sine and cos. We get it as sine theta divided by cos theta. If we take a ratio, the denominator hypotenuse get cancels. We get opposite side divided by adjacent side. So in a 6 trigonometric functions, 3 trigonometric functions we have defined it. First one is sine theta. Just refer the diagram. Opposite side divided by hypotenuse is a sine theta. What is a cos theta? It is a adjacent side divided by hypotenuse is a cos theta. And tan theta is what? One definition, we have to take a ratio of sine and cos, we get it as sine by cos as a first definition, or else it is if you take a ratio, hypotenuse get cancels, we get opposite upon adjacent side, that is a tan theta. Okay, you have to remember these three trigonometric functions. Remaining three, just it is a reciprocal of these three trigonometric ratios. Yes, let us begin that. So I am writing on the another corner. You can see here sine reciprocal. It is a cosec theta. So just write a reciprocal. So what it happens? Hypotenuse divided by opposite side. Next, cos reciprocal is sec theta, so we get hypotenuse divided by adjacent side, like this. Now tan reciprocal is cot theta, it's a reciprocal, first we get it as cos theta divided by sin theta, or else one more definition, adjacent side divided by opposite side. Like this we have to remember. So sin theta is opposite upon hypotenuse. Yes, sine reciprocal is cosec, hypotenuse upon opposite side. Cos reciprocal is sec. Just to take a numerator as a denominator, denominator as a numerator, that is a reciprocal. We get hypotenuse upon adjacent side. Next, tan theta reciprocal is cot theta. First reciprocal is cos by sine. One more definition is adjacent side divided by opposite side. In your textbook 8.1, so it is there for you as an introduction to trigonometric functions. So this is a simple way. With the help of this right angle triangle, you have to write sine and cos, and then if you take a ratio, you will get a tan function. And sine reciprocal is cosec, cos reciprocal is sec, and tan reciprocal is cot. So using this, so you can remember these are 6 trigonometric ratios. Now in a 8.2, we are using some of important results that we will discuss now. So in 8.2, we will come across the standard values. So let us begin that standard values. So it is a sin theta, next cos theta, then if you take a ratio, tan, then sine reciprocal, it is a cosec theta, cos reciprocal, it is sec theta, tan reciprocal, it is a cot theta. So you can hold your hand in this way. You will observe that this will be, it is equivalent to the surface. So you can say that it is a 0 degree. Just to concentrate, next finger it will make a 30 degree. Next it is making 45 degree. This is 60 degree. This is, see, perpendicular to the surface. So this one, so it is a 90 degree. So naturally, as a God gift, you can say this is a 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. These angles it will represent. So I am using these 5 fingers, that is using the palm rule. I am defining these standard values of a trigonometric functions. First one is 0 degree, next 30 degree, 45 degree, 60 degree and 90. Then you have to use, so you can take a book, take a one page. So this one we have to trace it on a paper. You can trace it like this on a paper. You can see here how I am doing. It's like this. Trace it. So tracing, we get this is a thumb, this is the index finger, middle finger, ring finger, little finger. We are going to get it this way. Okay? Yes. You can take a paper, just you have to trace it. You are going to get it in this way. Now, dear students, I will tell you, this we have to represent it as a 0 degree. This is 30 degree, 45 degree, 60 degree and 90 degree. Just you have drawn it on a paper, just represent 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Yeah. Dear students, now I represent these values on my palm. We call it as this is a palm rule. Just look at here. I told you this is 0 degree. 0 degree. Next, this is 30 degree. 30 degree. Next, 45 degree. 60 degree and 90 degree. Yes, I will represent all these 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Now, I give and I mention the number as a 0. Counting number I started. This is 0, 1, 2, 3, 4. So, I represent it as a 0 number 1, 2, 3, 4. And I use one formula, very simple, it is very simple. So, I am writing on a palm. Yes, you can write it on a palm. You can remember all these values forever. It is root x divided by 2. Yes, it will fit on your palm. So I told you, you have to draw a palm on your notebook, represent it as a 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. Assign a value as 0, 1, 2, 3, 4. And formula is, here it is root x divided by 2. I am writing here. So this much you have to remember. Very simple. And then I write, see, you can see here 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5, 6. 6 5s are 30. 30 values you can remember. Yes. Let us begin with the first value, that is sin 0. Just you can see here, hold your hand. See, thumb, what value I have given? It is a 0. Okay, 0 I have given. So let's take it as 0. Root 0, 0, 0 by 2, 0 degree. Next, 30 degree. 30 degree means we have assigned a value as a 1 to root 1. We get it as a 1. 1 by 2, yes, there is no further simplification. 1 by 2. Next, 45 degree. I have assigned 2 value, so it will become root 2. X as a root 2. Denominator 2, I write it as root 2 into root 2. 1 root 2 get cancels, we get it as 1 by root 2. Yes. Now 60 degree. 60 degree means assigned value is 3. X it will become a 3. So we get root 3 divided by 2. Now next 90 degree. 90 degree means it is 4. Root 4, 2. 2 divided by 2. We get a simplification as a 1. So using the thumb rule, using this palm rule, thumb I have given as a 0, 1, 2, 3, 4. These values I have taken in this formula. X as a 0, X is a 1, 2, 3, 4. Like that I have written all these values here. Then see, sine values, all values we got it. Cos is just, it is a reverse of sine function. Just change the direction. So it is left to right, just write it as a right to left. Then we get cos all values. So 0, no, I am taking the 0. Yes, 1 by 2, 1 by 2 I am writing. 1 by root 2. Then root 3 by 2. Then it is a, so which is from left to right. I have represented it as a right to left. So cos all values I have written. So further, now we have to find the solution for a tan. So tan is very simple. I told you definition of a tan is it is a sine divided by cos. Sine divided by cos. So I am taking a ratio of a sine and cos. 0 divided by 1 we get a 0. 1 by 2 divided by root 3 by 2. 2 get cancels. We get 1 by root 3. Then 1 by root 2, 1 by root 2 get cancels, we get a 1. 2 get cancels, we get root 3 by 1 or else root 3. And the next, any number divided by 0 is not defined. Yes, remember this is a new terminology, not that you are studying. Any number divided by 0 is not defined, so I write it as a short form ND, not defined. Now, sine reciprocal is cosec. Reciprocal, how to write it? I'll tell you the easiest way. That is, if I am having only the numerator function, reciprocal will be 1 by a. Suppose that if I am having a by b, then its reciprocal is written as b by a. Like this we have to write it. Yes, reciprocal is written. So 0 is only numerator. Its reciprocal is 1 by 0. I told you any number divided by 0 is what? Not defined. So I am writing ND. Then 1 by 2. It is in the form of a by b. Reciprocal is 2 by 1. I write it as a 2. Next we get a root 2. Similarly 2 by root 3. Next 1 by 1 we get it. Like that we have to write a reciprocal. Now cos reciprocal is a sec. Write all the reciprocals. 1 I am getting. Next 2 by root 3. Next root 2. Next 2 0. 1 by 0 it will become. 1 by 0 is what we are getting? Not defined. Then I am writing tan reciprocal cot 0 we get not defined. 1 by root 3 1 root 3 1 by root 3 not defined. We get it as a 0 like this. So you can see 30 values you can remember. It is there in 8.2 exercise. These are standard values. Many students they feel a difficulty in remembering these values. But I tell you dear friends, so using this technique in a 8.2 you can remember all 30 values. You can remember these values using a palm rule. You can remember forever. Okay, just it is a representation. Use of a 5-finger root x by 2 formula and giving a values from 0, 1, 2, 3, 4 here. You can remember. Now we will discuss. So far we have discussed 6 trigonometric ratios. It is defined in your first exercise. Second exercise you have all these standard values. Now in a third exercise some transformation formulas are there. So you will get confused which function whatever it is. Now I will tell you the simple trick how to remember this. Okay, that is in a third exercise. So for that I am drawing hexagon. See, you can see here. Name only suggests it is having a 6 faces. 1, 2, 3, 4, 5, 6. Then see, I am using once again basic. What is a tan theta definition? It is tan theta is sine divided by cos. Memorize this. Okay? Yes. Tan reciprocal is what? It is a cot. Just opposite I am writing. Sine reciprocal is what? It is a cosec. Just opposite I am writing. Cos reciprocal is what? Sec. Just opposite I am writing. Where all these values intersecting at a single point, I call this intersection as a 1. So first I write transformation formulas. Very simple. Here you can observe three parallel lines are there. First parallel line is sine and cos, it is a connecting. Second one tan and cot, it is a connecting. Next sec and cosec, it is a connecting. So first formula I write sine 90 degree minus theta, it is associated with the cos, so it is cos theta. Next tan 90 degree minus theta is cot theta. Next sec 90 degree minus theta, it is cosec theta. So I make use of a parallel lines. Using that I have written three formulas. Totally 6 formulas are there. So remaining 3 functions, how to remember? Very simple. I have moved from left to right. Now you should move from right to left. So first formula I am writing cos of 90 degree minus theta. Cos of 90 degree minus theta is sine. Next cot 90 degree minus theta equal to tan. Next cosec 90 degree minus theta equal to sec. So it comes in your third exercise. So using these 6 transformation formula, many of our problems you are solving. So usually what happens, sine of 90 minus theta, whether it is a cot, a cosec, sine, tan, sec, which one I have to write? It is a confusing. Then what you have to do? Draw a super hexagon. Hexagon it is, I call it as a super hexagon. With the help of this super hexagon, you can write these 6 transformation formula and you can solve any problem which is related to this transformation formula. So very easy it is. It comes in your 8.3 exercise transformation formula. Very simple it is. Very simple trick you can remember. Now in 8.4 you will come across some important formula. 3 are there. It is called as a trigonometric identities. This trigonometric identities, how to remember, that simple trick I will tell you. That is, we have to draw a hexagon and I call it as a super hexagon like this. And I write a formula as tan, theta definition is sine by cos. So tan reciprocal is cot, sine reciprocal is cosec, cos reciprocal is sec. Now where sine, all these values intersecting, I call it as a intersection point. I represent by a number 1. Now where sine and cos they come together, that part I will shade it. So I am here shading. So I do alternative. I leave as it is, I shaded this. I leave as it is, I shaded this part. So alternatively I have made this pattern. Okay. So now we have to move in a clockwise direction. So I take this direction as left to right and then come down. Here also left to right and then come down. Left to right and then come down. Then while moving left to right, I use a plus sign in between and here equal to. Plus equal to sign. Plus equal to sign. Just on a paper you can draw this diagram and you can memorize like this. So I call it as a do not memorize a technique. Very simple way to remember all this formula. Okay, yes. So let us write first formula Sine is there, I square it, sine square theta, middle I go to plus left and then right cos square theta equal to 1 square 1. So first transformation formula. Next 1 square 1 plus cot square equal to cosec square. Second. Third one tan its square tan square theta plus I am writing. Next one is coming 1 equal to sec square theta. These three trigonometric identities you are going to use in 8.4 and many of our problems you are solving. Okay, so I tell you once again, sin square theta plus cos square theta equal to 1. You have to move in a clockwise direction like this. Next, here it is a 1 shaded region you have to take into consideration. Okay, so 1 square 1 plus cot square theta equal to cosec square theta. 1 plus cot square theta equal to cosec square theta, like this. Clockwise direction. Next, shaded region is this. Tan square theta plus 1 square 1 equal to sec square theta, like this. Three trigonometric identities we have defined. So, dear friends, so during this COVID situation, see, to motivate about the mathematics and the importance of mathematics, I have made this one session as introduction to trigonometry. You will feel it as a difficult. I tell you, it is a very easy, and using this memory technique, you can remember this formula, and these formulas are important for your PUC as well. And concentrate your 10th standard syllabus. Do well, get a good number of marks. Yes. So my well wishes for all of you from Angadi College of Commerce and Science. Thank you very much for watching this video. Thank you very much.